Alright, so today it's day 41. I don't have that much time to do the recap, but I studied quite a lot today. I would say it was around almost 5 hours. I covered many topics in graph learning. I would say what was the most interesting? Probably network inference, spectral clustering, SVMs. Okay, I'm gonna show you just like something really quick. We have, for example, the SVMs, which are the stochastic block model. In this type of modeling in particular, okay, so basically within the graph learning, right, we want to understand the hidden structures of the data. So we can understand the relationships of the variables as if it was a graph. And then what we do is predict the edges. So it's the connections between the nodes, right? So a concrete example could be like, you could have, I don't know, matches of different teams. And then you assume like that there is like some kind of rule, some order. And you say, you know what? Teams, there is like some, I don't know which teams belong to each league, but when a team belongs to a specific league, they tend to have more matches between the league than matches against people that it's against teams that are in another league. This is an assumption, but this cluster could not even exist. Like this league could be like hypothetical, but the cluster can still manifest itself because it's like a hidden structure, right? But in this case, it makes sense, right? Because it's explicit. So you have like this hidden assumption, and then you want to understand the dynamic, like how much exactly is that if you're in a hidden league, and also it could be different for each league. So for example, for a particular league, it's higher the probability that a node exists, that the connection, that a match between one team and another is higher than for another league, right? And you have a way of estimating all of this. And a stochastic block model, essentially, okay, there are many types. This one is like the simplest one, the Erdos-Rayleigh mixture model. But there are like, the first one is the Erdos-Rayleigh graph, and then you make the mixture model and so on. But essentially, everything is like about computing using the EM algorithm, the expectation maximization algorithm, and you have to define, and all of these can be reduced as you have to maximize the elbow, which is a measure. It's a loss. You have to maximize that, and you do it by iterations. And yeah, that's the main intuition. Yeah, and then you have other stuff like spectral clustering, which is a mapping, like from a graph into a geometrical space. That's very interesting. But yeah, I'm gonna stop now. Maybe someday I do like tutorials covering specific topics and giving like the high order intuition, because I believe that I've noticed that the tutorials that are in YouTube are either too practical, like either too easy, they do not cover the math well enough, or are too technical. There are like lectures from a university and they don't cover like they are not simple enough, like they don't give the intuition. For me, it has to be like first the motivation, what specifically are you solving with like the method you're using, then like the high order intuition, then the solution, like the algorithm, like the pseudo algorithm, and then the actual concrete example. I think that's a good way to explain. All right, I'm gonna stop now.